Hello students, today we're going to be talking about medians, altitudes, and mid-segments. Please make sure you take notes as you go and do the completion survey once you are finished watching the video. Okay, so before we get into properties, I want to make sure we understand the definitions. Please make sure you're writing these down. The mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. So to give you kind of a visual, in this first one here we've got AC, whose midpoint is D, indicated by those two markings there. And then we have line segment CB, whose midpoint is E, again indicated by those markings there. The mid-segment is taking those 2 points and connecting them together. The second word is a median. Median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So we're going to choose one side, okay, which would be, say, this vertex here and this side here. We're going to connect it to the midpoint so that these two sides here are equal. Now keep note that this is just one of them. We can create two more medians in every triangle. So essentially we have 3 in every triangle. And the last one we have is the altitude. The altitude is similar to the median in the idea that we go from the vertex to the opposite side. But the key thing here is that it's going to be a perpendicular segment from the vertex to the opposite side. Now we have 3 cases here. It can be inside, outside, or actually it can be a side of the triangle. So you can see here, this is an example of where it's going to be meeting inside the triangle. Now, just because it's perpendicular and hits the other side does not mean it's hitting the midpoint over here. As you can see, this is a little bit off to the right. But that doesn't mean that it can be hitting the midpoint on the opposite side. But in this case, it's not. Here's a case where it's meeting outside the triangle. Again, typically when you have obtuse triangles, you'll see it meets outside the triangle. And the last case is where it meets on the triangle, and this usually happens with our right triangles. Now keep in mind that there are 3 altitudes, just like there are 3 medians, and that means it can meet in a different place. So for example, the altitude for this one would actually hit the opposite side inside the triangle. Same thing with if I were to connect it here, and so on and so forth. So now that we know what the definitions are, we're going to go through and discuss the properties of a midsegment. First, the first thing about midsegments is that they're going to be parallel to the third side and half the length. So for example, here's our midsegment. This midsegment is parallel to this opposite side here, or this third side, AB, as well as this length here being exactly half of whatever the length of AB is. Okay, so if this was 20, then this would end up being 10. And use a little bit of common sense. If we're going from smaller to bigger, we're going to double it. If we go from bigger to smaller, we're going to cut it in half. So let's do an example with this. So we're going to find the length of TU, UB, and QR. So the first one I'm going to do is find TU. The side that's parallel to it is SR. I know that the length of SR is 40. TU has to be half of that, so half of 40 is 20. Continue on to do UB. Again, UB is parallel to the side QS. So QS is 50, UB has to be half of that, so half of 50 is 25. And then finally, if we have QR, well in this case I'm looking for the side of the triangle. I know that the TB, which is parallel to it and also is the mid-segment, is going to be double that. So if this is 30, if I double that, I'm going to get 60. Now keep in mind that these are midpoints as denoted in the direction. So if I actually wanted to find a little piece, QU instead of QR, just keep in mind that this whole thing is 60. This little piece is going to be 30 because that's going to be exactly half since that's the midpoint. Now we have one more definition I want to make sure we get before we get into properties using concurrent lines. But these are when we have 3 or more lines that meet in one point. This is the point where they meet is called the point of concurrency. Now in a triangle where we have concurrency of your medians, so if we were to take all 3 medians and draw them together, is called the centroid of the triangle. So in this case, point E is the point of concurrency and the centroid of the triangle. Now, if we were to connect and find the point of concurrency for our medians or the centroid, there's a relationship within. So what this is saying here is the medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the point of the opposite midpoint of the opposite side. So what that means is, if I were to have this length DC, what I know is that comparing it to the length DJ is that is exactly 2/3 of the whole length. So whatever the length is here, I can take 2/3 of it to be DC, which also means that CJ is 1/3 of the whole length here. Similarly, for FH, I know that FC is going to be 2/3 and CH is going to be 1/3. And once again with EG, again I got to go from vertex to the centroid, that's 2/3, and the GC is only 1/3. So in each case you're going from the vertex to the centroid, that's going to be 2/3 of the whole length of the median itself. So let's do an example like that. So in this problem here, I know that the length of XA is 8. I want to know what the whole length of XB is. Well, for this case, I know that the length of XA is going to be 2/3 of XB, because again, it's going from the vertex to the centroid. So I'm going to substitute some values in here. I'm going to take XA and replace it with an 8. Now at this time, you can either multiply by 3 and divide by 2, or you can multiply by the reciprocal. It's up to you how you want to take the process. I'm going to multiply both sides by the reciprocal. So in this case, on the left-hand side, I'll do 8 times 3 and divide it by 2, and I get 12. On the right-hand side, the 3's and the 2's cancel out, so I'm left with just XB. So my final answer, is XB is equal to 12. So if XA is equal to 8, I know that AB is going to be equal to 4. You can either do 12 minus 8 or know that AB is 1/3 of XB. So now we have a similar thing for altitudes. The concurrency of the altitudes is called an orthocenter. The orthocenter triangle is where all your altitudes of a triangle are concurrent, not congruent. Okay. So again, it's different from the medians. Medians, again, they meet at the midpoints. They're called the centroids. For the altitudes, they're called the point of concurrency. When you draw all three, is called the orthocenter. Now we have 3 cases for this. The first case is when we have an acute triangle. When we have an acute triangle and we were to draw all 3 altitudes from each vertex, it's going to meet inside the triangle. We have ourselves a right triangle and we were to draw all 3 altitudes. Since the right triangle has 2 sides that actually represent the altitude and the one that's not, we're going to meet on the triangle. So this here would be our orthocenter. And then finally we have the obtuse triangle. So here's the actual triangle itself, and remember we're going to have ourselves essentially 2 that are going to be outside the triangle. Now while this altitude, technically you would normally see it stop here, that is a line, and we're going to continue the other one as well. Now this is the one that the altitude ends up being inside, so we're going to continue the opposite direction. When we are to continue those lines, you'll find in an obtuse triangle it's going to meet outside of the triangle. So what I'm going to do is I'm going to do an example to find the orthocenter. Okay, so in this problem here, I'm giving you 3 points. So I got 1, 3, 2, 7, and 6, 3, and we're going to find the orthocenter. Again, note that we are going to be finding the altitudes. So the best way to really do this is to draw the triangle and draw the altitudes in. But you want to make sure that you're being accurate. But I also want to show it to you using algebra as well. So you can do it either way that you want. Now we're going to start with doing it kind of on the easy way. So we're going to start with the line that's horizontal. Again, remember the altitudes are perpendicular to the opposite side, so it's got to go straight up and down this direction here through that vertex. So that's the easy one to draw. The other one, which is this blue line here, it's got to be perpendicular to BC. So what I can do is, I know that here I'm going down 1 over 1, so it has a slope of -1. So I know that my line here is going to be going up 1 and to the right 1, and so on and so forth, or a slope of 1 in order to be perpendicular. So the best way to do this is to actually draw the lines in, and you can find that orthocenter only needing 2, because they're only going to meet in that one spot. And so in this case here, our point would be 2, 4. But let me show it to you also using algebra. So once again, we're going to do the first one here, which is the straight up and down line. That's an x equals a number when it's perpendicular to, say, this is y equals a number. And specifically, this one is going through 2. So in this case, we're getting x is equal to 2, would be that equation. For the other one, we're going to find it perpendicular to BC. Again, we know that this is -1, so the slope is going to be a +1. And I've got the point A3, and we did problems like this in the last unit. Given a point and knowing the slope is 1, I'm going to find the equation of that line, and in this case I would find that the value of b is 2, so I have y equals 1x plus 2. And then we're going to find the point of intersection. So I'm going to use x equals 2 and y equals 1x plus 2, and I'm going to solve for the point of intersection. Well, the nice thing about this case was we already knew that x was equal to 2 because that was a straight up and down line and it can't go anywhere else. So all we had to do is substitute that in to get y. So if I substitute that in, I get 1 times 2 is 2, plus 2 is 4. So I know that y is equal to 4, and that therefore means our orthocenter is 2, 4. Okay, if you have any questions, please bring them to class tomorrow. We'll go over a couple more on how to find the centroid and the orthocenter and so on and so forth. But please make sure you do the survey that follows this video. See you tomorrow.